Okay, so I'll start by introducing Cleo from kind of the product perspective, what it is that we're trying to do with our assistant for financial health. Then I think within this, you'll be able to see some of the opportunities from LLMs, some similarity of our problem to some things that ChatGPT solves. I'll talk about what our integration with LLMs has been so far, the early wins that we have, and what kind of challenges those raise, and then some key learnings that I think can apply to lots of applications of this technology. So who is Cleo? Cleo is the first digital assistant dedicated to financial health. It's an app, users download it, connect their bank account data from various accounts in a read-only way, and then this dry bank statement, credit card statement data, they have a conversational interface to it that's full of humor, pop culture references, really help to break down difficult conversations about money for Generation Z. And it's infused with humor and our distinctive tone of voice, which is very important for our brand. And what are we trying to do with this? What's the user value that we bring? So Cleo's mission is to help our customers create a life beyond their paycheck and improve their overall financial health. And we can break this down into a few steps. There we go. First, they need to know where their money goes. So these kind of spending insights, talk to your bank statement kind of thing. You need to make a budget and stick to it. Then through ongoing coaching, cut back on expenses, refine the budget, and get to a point where they can build savings and an emergency fund and become less reliant on debt. So when we're talking about a digital assistant for personal finance, this is really about, like, it's not about investment advice, it's about spending coaching, how can I save money, just like the features that you got out of your conversation with GPT. I wonder if our app description was in the Common Crawl going into GPT's training data, because yeah, we've been going since 2016. And so I mentioned the spending insights already, but users aren't just after spending insights. The chat has a variety of use cases within Cleo. They also use chat for navigation. So for getting to any product feature, they might ask to see their budget, ask for a cash advance, ask to see their credit score. And then there's also the more traditional, like, customer service use case. So people say, I'm having trouble connecting my bank account to Cleo, like technical issues, account admin. And this is something that's familiar to a lot of businesses as a place where they want to make an automated chat assistant that has access to the company and customer account information. And part of the reason that we have so many use cases for chat in Cleo is that Cleo is really a chat native company. So when it started out, it just existed in Facebook Messenger, and users could only interact via chat. And our founder made a bet that the future of human-computer interaction would be through natural language. Now, since then, we've moved away from Facebook Messenger. We have our own app. Users can navigate to other screens that look more like your familiar personal banking screens, budgeting app screens. Chat remains kind of this core part of the Cleo experience, which is how we build this branded conversational interface. Yeah. Do you have any tips for that?
I'll change the battery. Maybe that's it.
Okay, I'll just stop on this for now. So now I'm going to get a bit more technical about how our chatbot worked a year ago as the starting ground for how we could integrate LLMs into our stack. So we've been using machine learning for quite a few years. but just in a kind of natural language understanding, intent classification kind of way. So we would take just the most recent user message, put that into our machine learning intent classification, and then use that to pick a pre-written response. This could be a template, so it would need some user data, some numbers retrieved from our database that's connected to that read-only bank data. So we can put the right names and numbers into the response when we populate the template. And we also want the users, sometimes the users need like a call to action button. But if the template was static, then we can also just pick some buttons that would make sense, so that the users don't have to type a reply, but they could tap a button to perform some action. So we could build a lot of features with this system. For example, I was able to ask, what did I spend on groceries so far this budget? And then this would go into our intent classifier. It would say, right, this is a kind of spending breakdown intent. And through some named entity recognition, pull out the groceries category and then correctly respond, so far you spent 113 on groceries, Benjamin Garrison, keep an eye on those receipts. So Benjamin Garrison and 113 are the values that are pulled from the database into the template. And then it gives me a button to navigate away from chat and see a budget breakdown. But if I reply in natural language instead, because I'm one of these, I'm committed to the conversational interface and I'm used to using ChatGPT, how did that 113 break down? Where did I spend it? It can classify that as something to do with a spending overview, but it really fails to continue the conversation. It gives me some buttons. I would probably have to tap this by merchants to get my spending breakdown of where I spent money on groceries. So these generative AI opportunities, a lot of them Sarah already covered, but this way of giving greater personalization. The large language models would allow us to cover way more user needs than the pre-written responses. So they would allow us to cover this long tail of user questions that we haven't written specific intents and specific handwritten responses for. And also, many of you from using ChatGPT, you can refer back to previous points in the conversation. It has quite a long context window, and so using a model like this offers an obvious way to make sense of co-references like that $113. It can go back and see what I was talking about. So could we just replace all of these gray boxes on the right with GPT-4 as a first pass? What could this do for us? Well, not in some situations, but yes, in others. So we played around offline internally, just feeding some of the customer conversations in and seeing what this could do. And for generic questions like, what can this bot do? Or as Sarah showed, like explaining financial concepts, what's a 401k? Yeah, GPT-4 can do that. We could maybe put in a generic system prompt that explains what the app is. But when the user starts asking things like, can I get a refund? An LLM is happy to say, like, sure, the refund's on its way to your account now, when in fact nothing has happened. And this would cause like a customer service nightmare downstream from that. Or if the person's asking how much I spent at McDonald's last month, they would get a hallucination unless we were able to put the exact information into the prompt. And then there's some other areas where it's kind of dangerous from a regulatory point of view. If people are asking like, what crypto should I buy, something like that, we don't want to be generating responses that we might giving advice that we might not be allowed to give. Or giving some wrong information. So instead, we decided to integrate LLMs at each stage, the classification, the retrieval, and the generation steps, as a way of keeping this modular and keeping more control over where the LLMs were going in. So on the classification side is a bit easier, because the classification side, we're not this is just outputting like an intent label for what the user was trying to get, and so we're not showing that directly to the customer. And that's where we could take advantage of the larger context window. Instead of the most recent message, feed in the whole conversation in the session so far into a different intent classifier, which was a fine-tuned GPT-3 model, and output an intent label. And then once we have the intent label, there are a few different pathways through to getting a response. So I'll go through each of them. In some cases, we could decide, okay, for this intent, we're going to stick to our templated responses like we did before. For other intents, we might have written a custom prompt for that intent. And the prompt can retrieve lots of user data just in the same way that the templates could. So you can write the prompt and say, okay, insert here the top merchant from the past month and the amount they spent and the user's name and a category breakdown and all this personal data aggregated from their bank statement into the prompt. Another important aspect of the retrieval is our customer service information that might be relevant. So for that, we made our own retrieval-augmented generation system by taking our customer service FAQs, splitting that into paragraphs, indexing each of those with GPT embedding, and then we could look up the FAQs that were most relevant to the user's query. Once we've retrieved this user data, if we've gone the route of taking one of our templated responses, that has already retrieved some information that might be relevant to the intent. So one of the approaches we did was generate the response that Cleo would have done, and then send it to GPT for possible rephrasing to put it into conversational context. And then finally, if these responses are generated by GPT-4, then the call to action buttons from a template just might not make sense. GPT-4 might have rephrased it in a way that navigating to your budget would make more sense than navigating to a cash advance. So we made a suggested action classifier or an action recommender system that I will show you a little bit later. So what's it able to do now? So now if I ask, how did that 113 break down? Where did I spend it? It's able to give me a list of merchants where I spent money in the groceries category and amounts for each one. And then it follows up with a tip saying, have you considered consolidating your shopping to one store? Maybe do a bigger shop that's better planned at one supermarket. And that's because we put some guidelines into the prompt saying, follow up with a spending tip and end the message on a question, just as a way of experimenting with making it more useful. And then I can also ask a question like, how can I spend 200 less than last budget? And in this case, it can go through the records of my spending that are in the prompt and say, yeah, pick out a category where it thinks I could cut back and offer me a tip for cutting back on that category. So this is really powerful, makes it a much more natural conversational experience. Here's another example where somebody is getting advice from Cleo on one category, which is like their spending on takeouts, and giving them advice about how they could save some money there. And then our user says, no, I already am prepping all my meals. I can't see any way to cut back there. Do you have any other tips? And then it goes back to the data, picks out a different category about transport, and starts offering advice on that. So unlike the previous system, where basically it was like the machine learning was just at the top of a decision tree, where it would route the person into a predefined conversation chat flow. Now it's much more free form. You can type things back to it, and it responds conversationally. And then sometimes users want to do something. They want to actually do something. They don't just want some information about their spending. They don't just want some advice in natural language. They want to perform some action. So this is why our action recommender comes in. And what we've done is taken some of the top actions that people want to perform within Cleo. One of them is checking eligibility for a cash advance, and then making a classifier. We actually ended up using the Dilbert model in this case to pick the appropriate call to action based on the message that GPT-4 has generated. So now I want to talk a bit about evaluation, because these conversations that I've demoed have all looked great, but how do we know more systematically where the hallucinations are coming up? Has this improved the chat experience overall? And so evaluation is really important. And we've made our own in-house tooling and started with teams like content design and customer service, although we're now looking at outsourcing some of these questions as well to like a data labeling partner. And we've labeled about 10,000 different conversations to date. And so this is able to give us a much more systematic tracking of quality and pull out specific themes of including by intent. So like, okay, this intent has reached a threshold where GPT-4 is improving the response. Let's like roll that out to more users. On this other intent, let's keep it to the pre-written responses. Maybe it was poor on utility or poor on factual accuracy. So we can really test this intent by intent, and this is really helpful for prompt engineering as well. So prompt engineering, you say like, yeah, you can experiment with the prompt and reduce the hallucinations, but often you're doing that based on like a couple of examples where you saw a hallucination and you've improved it, and then you want to use this more systematic evaluation to check, okay, is this improving quality across the board? We're a very data-driven company. We like to see numbers of quality going up. So some more numbers then. We've seen a 62% reduction in intent recognition errors. This is by switching from our previous intent classifier, which was a fast text model, to fine-tuned GPT-3. This is even though we've reduced the size of the training set and increased the number of intents just because of the transfer learning capabilities of GPT-3. Secondly, we've had a reduction in customer service contact rate, partly thanks to our retrieval-augmented generation system, and also because some of our intents are actually cover like very commonly asked questions, and so we're able to write custom prompts for that can answer the customer's question directly. And finally, an increase in response quality for the most frequent intents that we judge through that evaluation system that I showed. But what are some of the challenges that it raises? What are some of the new challenges we have now that we've started to roll out this generative AI system? Well, one of them is alignment with Cleo's terms and conditions, what Cleo is allowed to do, the tone of voice. So if I type into Cleo, what stocks should I buy? Now, it's great that Cleo backs off and says, sorry, I'm not really equipped to give advice on specific advice on stocks. But On the downside, Cleo's written a whole essay here that isn't really on brand. A proper Cleo response would be fewer sentences, much more snappy, Generation Z, maybe an emoji at the end. So this is an area where we need more prompt engineering, perhaps fine-tuning on examples of Cleo's tone of voice. And then the other concern is increased costs and latency. I think since this meme was written, you could add to it risk of using GPT-4 API everywhere, like boardroom coups. And so we've been looking at diversifying beyond GPT-4 for sure, but also really finding that GPT-4 maybe is a good model to use for prototyping, but for scaling up and for applications where you need it to be faster and lower cost, then fine-tuning smaller models is a good way to go. And so we've had some success so far fine-tuning GPT 3.5 to replace GPT-4 in some circumstances, and also looking at fine-tuning open source models that we could host ourselves and that would be even faster. So the key learnings that I'd like to go through, the first one is evaluation. So integrating these models is much easier than proving that the quality has gone up and that the hallucinations aren't too severe. So really getting the evaluation set up as early as possible in the process is very valuable for making sure that the project can go quickly. Otherwise, you get to a situation where you have a proof of concept that can do something amazing, but you're too scared that it wouldn't work at scale, or unsure how to measure what impact it would have at a larger scale. The second is modularity. So I was really surprised. I thought maybe 6 months ago that this old school intent classification approach, that was all going to go out the window. We were going to lump these intents together, and each broad topic area was going to be handled by maybe its own dedicated LLM. But the modularity that the intent classifier gives you is really useful. So we can turn on and off the generative AI for each topic area. We also noticed in our fine-tuning that if a particular intent, so an intent is basically just like a topic area or a type of question that we get. If a particular type of question wasn't present in the data for the fine-tuning, then in the evaluation of the fine-tuning, the fine-tuned model would do really badly. So we need to make sure that we stratify our training data and maybe augment some of those examples for the intents that are underrepresented. And yeah, intent classification is really valuable there. And finally, retrieval. So this was something that Sarah talked about as well. One of the best ways to avoid hallucinations is to retrieve the correct information and put it in the prompt. Otherwise, this is a bullshit machine that's very happy to say, oh yeah, sure, you can have a refund. The money's on its way to your account right now. So retrieval is another area that we're going to be investing a lot of time in, thinking about how we get this data from the dry bank statements and credit card statements into the prompts so that we can use generative AI more effectively. So thanks very much. And yeah, happy to take questions. I don't know how much time we have for questions.
2 minutes.